Hi everybody, I'm Luca, and today I'm going to talk about the latest trends in web cloaking. For those unfamiliar with the topic, web cloaking is a technique that some webmasters use to deliver different content to real users and bots. This is because while the users are the ultimate consumers of most of online content, bots are the gatekeepers. They're the ones that decide which search query corresponds to which site, and if a site is safe or not to visit. So because of this, cloaking is very effective for a few things. One is SEO, so artificially inflating your website rankings by providing a different view to Google and Bing, and also to infringe ad policies. Ad companies check content before putting it online, so if you want to avoid this check, you can just present something else to the ad company. It's also used for malware distribution, by flying under the radar of security bots, but we're not going to talk about that today. So cloaking the definition of cloaking has become less clear-cut over time because of responsive design. Here we have an example. Wikipedia delivers a subset of the textual content of the page on mobile devices, and also it's on a different domain. But semantically, these views are the same, so this is not considered to be cloaking. Whereas here we have an example of cloaking. We have a scareware campaign that is just on mobile devices, and the desktop view is just 404. There's nothing to see here. Carry on. We have shown that the techniques that cloaking sites use are becoming different, and this makes it harder for detection. It's not just the situation is not just checking IPs, user agent, and referrer, but it's becoming more complex. So we set out for trying to find these new techniques, identify the current state of cloaking, so how much is there of cloaking sites, and explore if we can move the detection from the crawler side to the client side in a privacy-preserving manner, because that's a better way, a better position for us to detect cloaking. We need to find these new cloaking techniques, and to do that, we turn to the black market. We have crawled a few black market sites, and we saw the comments that people were saying about particular cloaking software packages, and we ranked them, and we found the top 10, and we acquired them. This is an example of one of them. It cost $3,500, so it's quite expensive. And essentially what it is a smart reverse HTTP proxy. It decides whether to deliver real or fake content to the visitor based on a variety of signals that we go through. The three main categories of them are network browser and browsing context. Essentially, with the software, you can really go in deep and specify your target audience very well. You can say, I want just mobile users in Spain on a particular mobile carrier with Spanish language installed in a browser that come from a search engine in the Spanish localization during daytime in Spain, and so on. It's really, really quite well done. The price tag also comes from the fact that the admin interface of this cloaking package makes it very easy to deploy. This is how it looks like. Essentially, what you do is that you provide keywords that you want to target for SEO, such as cheap electronics, and the money site you want to send real users to. And what the site will do for you, it will go on more than 20 search engines on different localizations, search for your keywords, collect a corpus of text related for your keywords, and start spinning this corpus and drip feeding on your site so that continuously your site changes and it looks like it's actively talking about these keywords. It also has other services like plagiarism detection to avoid being demoted because you're stealing content, and you can measure how well you're doing in the rankings. After studying all these 10 cloaking softwares, we have a selection of the techniques here. There are a combination of old techniques that we were aware of and old techniques with new little spins and completely new techniques. This is well-known, is HTTP referrer-based cloaking. The difference here is that now they're using also negative matches. So if you have a keyword in your search query that we're not expecting, they will not deliver you the true content of the site. And also, if you pack too many keywords, try to find the ones that will work, they will not do that. A technique that they heavily rely upon is IP blacklisting. This is one of the most comprehensive blacklists we have found. It contains 51 million IPs, about 1,000 subnets, and it includes 30 security companies, even hacking groups like CCC in Germany, so they really have a good pinpoint of who's owning which IP. And also it has VPNs in it. Cloaking software are participating, most of them, in one shared blacklist that has about 60,000 IPs and costs $350 a year to get. And interesting, all the sites that buy this blacklist also contributes back the IPs and HTTP headers of every visitor. And the person in charge of the blacklist claims to have some machine learning in place to detect the bots, sends twice a day updates to each site, and also has honeypots around the web that will not ever get, according to him, real visitors. So it collects bots IPs this way too. Another thing that they do is use DNS to do cloaking. So here we have a bot that comes in, and they check the reverse DNS name of the IP of the bot, and if it matches some of substrings that they have, they will not deliver the true content of the site. Another last thing that they do is to check the browsing pattern on the user through the site and only deliver the real content if the user follows a precise pattern and within a certain time frame. Here we have the user that has to get the home page and click on something within 10 seconds, otherwise it doesn't get the true content of the site. There are more techniques I'm not going to talk about, essentially geolocation both at the city, country, and carrier level, JavaScript redirections, and user agent, which is not used that much anymore. It's more a very broad checks on whether the user agent string contains Google or Bing or something like that. Now that we have a good idea of what cloaking techniques look like, it's interesting to see how much cloaking is there and how prevalent are these techniques. To do this, we built a system that essentially is a browser farm with a featureization of the data that we collect and a classifier. And this is our browser. We try to mimic what 3 families of bots look like. Google bots that really say on the user agent, I'm Google, and they come from a Google IP. We have undercover bots, let's say, that are coming from VPSs, but they use a real user agent, and they might or might not have a referrer. And then we have realistic honey clients that come from mobile networks and residential IP, depending on whether they're mobile devices or not. They have real browsers, and they have the right referrer. We collect all network traffic, HTML, screenshots, and before and after taking a click on the biggest element of the page. And from this data, we extract features that are related to the comparisons of the various views that we get. And we extract syntactic features like comparison in the HTML and the visual text level. And the same thing on the screenshot side, we compare pixel per pixel. But we also go in the semantic level, and we extract topics both from the HTML and the screenshots, and we try to compare those two. Our classifier has under 1% false positive rate and about 82% true positives. And it's just been trained on 20,000 Cloak storefront that we got for previous research. With this, we can now say how prevalent is cloaking. We can see that for keywords that are prone to cloaking, like diet pills, health-related things, software, and luxury storefront, we have about 5% cloaking on AdWords. That ads cloaking was never measured before, so that's interesting. And also we have 12% cloaking on Google search. The techniques that they use are also interesting. The traditional techniques of IP referrer and user agents are just using 1 out of 5 or 1 out of 4, so 20% cases, whereas the more recent techniques are much more in use. In search, about half of cloaking is based on JavaScript, and about 1 out of 4 in ads. And also, a lot of cloaking sites wait for clicks. So a user interaction has to be there in the anti-cloaking pipeline. Otherwise, you'll not see the real content. Talking about delivery of the uncloaked content, we have that ads have a preference for delivering the content on the same page and not the redirect. That's what search does. And sometimes cloaking can be really subtle. Here we have an example. The cloak page, the one that the search engine sees, clearly states that you'll be billed for this service and you have to provide your phone number because they billed you through the mobile carrier that you're using. Whereas the uncloaked version doesn't have that. And in the little Italian there, it says that you have to disable your Wi-Fi connection because they want your phone number. So they have a deal with the carrier to get the phone number and bill you automatically. Interestingly, a lot of the cloak content that they serve is 404 or 500 errors. So if you see something like that, it might be that the website is cloaking. Talking about the future, we want to move cloaking detection on the client side because that's a vantage point for us. We see the true content that is delivered to the users. But this poses a challenge because we don't want to invade the privacy of the users. So we propose that search engines and ad networks would include an additional parameter when they serve their ads or search results that explains the topics that the bot has found on the page, so that when the browser gets this information, it can independently check with his own machine learning model if the topic that it sees are the same. This poses challenges like we have to serve a machine learning model and they can introspect this, but this we still think it's a better solution than having the crawler try to find the correct carrier and so on to uncloak a site. So the takeaways from this research are that cloaking is still there, it's still a problem, and it's evolving, trying to avoid the previous detection techniques. Also moving forward, we want to move client-side anti-cloaking pipelines because we believe they're better, and also semantic checks are really useful in telling apart the very hard cases when cloaking is subtle. With this, I thank you, and if you have any question, please speak up.
Hello.
Yep.
Hey, great talk. So did you measure coverage or false negatives?
False negatives. So there it was about 20%.
I'm more interested in the methodology. How did you measure it? Yeah.
We have a labeled data set of Alexa domains and in this case, just Alexa domains at work. The problem with that is that some of the top Alexa sites also cloak. So it's kind of challenging to measure this because we saw that cloaking is also present there. Yeah.
You could also measure the traffic impact.
Sorry?
You could also measure the traffic impact from clocking.
Mm-hmm. Thank you.
Hi, I'm Jim from Facebook. I was wondering if you noticed any different behavior with link shorteners and like redirects instead of just HTML content?
We didn't look into that. We just look at search results and ads.
Cool.
So do you have any ideas about how attacker can do the next step? How can he evade your detection?
Well, I personally believe that segmenting the market and just cloaking on a specific carriers is very challenging because we cannot have every security bot, every search engine on every single carrier. So that's a challenge, and that's why client-side detection has to be there.